2018 Volvo XC60. This is the gasoline 4-cylinder model, and there is our engine code B4204T23. It's nice of Volvo to start putting these in. On previous models, it was very hard to get the engine code if you don't have VIDA, but now they've started putting the stickers in. This is a new car bought by my client, and whenever I have clients who are loyal and they have new cars, I always take the data for the cars in preparation for any diagnosis I need in the future. As most of you are aware, a lot of the data for these sensors and the parameters are not given properly in the service manual. So when you have a car that is running well, it's always wise to populate your own database with these. So that's what we're going to do today. This car is not a diagnosis, it's just for taking data. So I'm just going to run through the preliminary things that I do when taking data for new cars. First thing is I take my fuel pressure readings. This has a high pressure system. It's a direct injection. So I will take the high fuel pressure, and nice of Volvo to give us also a low fuel pressure. So we're going to take also the low fuel pressure, both at idle and at load. Next thing is this car has got dual VVT. We will take our VVT angles at idle and at load. Next is to get the base ignition timing at idle. I don't usually take the ignition timing at load. It's good to have it, but usually at idle, when you see a drastic ignition correction, then it usually points to a problem. So we'll take ignition timing at idle. Next is our injector voltage and current profile. And this ones I just normally take them at idle. And our injector wires are right at the top here. Next we'll take the turbo pressure. So this is a turbo engine. We're going to take the turbo pressures at idle and go on a test drive, and you take turbo pressure at wide open throttle to see what your minimum and maximum pressures are. The other thing is to take the charging voltage at idle. Now this is very important. Do not assume that your vehicle always charges at idle. I have seen some vehicles, notably the Nissan Juke. I don't know if it's the first or the second series, but the Nissan Juke does not charge at idle most of the time. So I'm going to see if we have got charge at idle, what it's supposed to be, and also at load, or when we add low electrical loads, what our charging voltage is meant to be. Then we will take the coolant temperature, want to see what it is nominally like. And lastly, we're going to take our mass airflow reading, both at idle and at wide open throttle. So those are the things that we get sensor wise, and then with our scope we're going to access the engine computer and take our cam and crank correlation for the timing of this engine. Now this is a 2018. Most people are used to the XC60 up to 2017. Their ECUs were in the cowl panel. No ECU in this cowl panel. The ECU for these cars is located under the left wheel well. So tire needs to come out, and we're going to access our ECU from there, and that's where we're going to take our cam and crank correlation. And then most of the other stuff we're going to do from the DLC with the scanner. So that's it. Let's get going. Alright, so in the car, we're about to start gathering our data. Our tablet is ready. We're going to put the key on. Cluster is on, and we're going to go to not vehicle coverage. We're going to go to all systems diagnostic and do a VIN scan. Now I'm going to go to health report. Report is done. One abnormal event. Only abnormal event is antenna circuit 3 circuit. So these Japanese cars come with TV antennas that have got subscriptions of Japanese TV stations. They're usually removed before the vehicle is exported. I'm not worried about that. We need to go to engine control module and we get our module information. That module information is important in case there's a software update or there's a TSB out to address an issue. You need to know whether your software number is matching the software of concern that needs to be updated. So this is another thing that needs to always be taken into account. And we're going to start the car now. So the car is running and we're going to read our data stream. For now we'll select all.
No ETC card is inserted.
ETC is electronic toll control. That's another Japanese toll collection system. So for now I'm just scrolling through. The reason I'm doing this is, if you notice down here, if you notice as I scroll up, you have no data and then the data populates. If you do not scroll and you take a report, we'll notice that your report will not have any data. So these are readings that I'm taking when the car is in park at idle. And before saving these readings, do yourself a favor and make sure that your coolant temperature is up to temperature. You don't want to do this when it's cold. Things will vary when the coolant heats up. And how do you know whether you are at temperature or not? It's very simple. Right now we are not sure whether 82 degrees is still warm-up phase or normal temperature. What we're going to do is we're going to hold the throttle up at about 2,500 RPM until the cooling fans come on. When the cooling fans come on, we know we are at operating temperature. So let's look at our fan. We have it. So there's our cooling fan. We're going to wait for the cooling fan percentage command to go up, and then we will know that we are at operating temperature. This may take some time, we need to be patient. And there we go, our cooling fan is starting to ramp up. It looks like we are not raising any more in degrees centigrade, which means with our coolant fan, the cooling fan has actually gone off and it's come on again at 15%, but our temperature is not rising anymore. Oh, we still are rising. We're at 90 degrees centigrade, so let's give that some time to go up. And we are stuck at 90. So that means the temperature regulation has reached its optimum. And that tells me that the optimal operating temperature of this car is 90 degrees centigrade. So let me get our list out, and I'm going to show you how I normally take these readings down. Let's start with the fuel pressure. Okay, the first thing we can do is to take this entire report, but remember, you need to wait as you scroll up. Wait for your values to update before you scroll again, because they will not update as long as they're not showing on the screen. And the reason why the scanners do that is to make them quick and efficient. Otherwise, if it updates all the data, the bus speed will reduce and the refresh rate will be extremely slow. So wait until you see numbers changing, and then you scroll up again. And that's it. Now that you have all your data updated, you hit report, and it'll generate a report of the entire data list. I don't want to add a comment, and we're going to generate PDF, and that is the PDF you have, and that gives you all your values at hot idle. This is very important. You'll save this, and then now we are going to come and take readings which are more custom tailored to what we need. So you're about to start gathering data, and I just want to show you one thing that's crucial. Before you gather data, pull up your fuel trims and make sure that your fuel trims are within acceptable range. Modern cars, plus minus 5% should be the maximum you see. We are within that range. I'm good with this. That means that this engine is running optimally, and whatever data we collect here is optimal. If you see deviated fuel trims from here, you need to stop what you're doing, first diagnose the car and fix it, then you get your known good data. But after looking at this fuel trim, I know we're good to go. First thing I want to focus on is low and high fuel pressure. Let me look for those. And I can see we also have a data plate for oil pressure. That is excellent. Wonderful for Volvo to give us this data. So right now we are going to focus only on the liquid pressures. Let's do engine oil, fuel high side pressure, and we're also going to see the required value, and the low side pressure. We're also going to look at the temperatures. All right, let's focus on these. Now, do not be alarmed by your fuel temperature. Direct injection systems have got very high fuel temperatures. Why? Because when you compress liquids, they raise in temperatures. So it's not uncommon to see these raise up to even 85, upper 80s. Where you should start getting alarmed is if you start going towards the hundreds, then that's a problem. Okay, so this is at idle. So I'm going to mark this as idle. We take this report, and then you're going to mark this as fuel pressure at idle. And then we're going to go on a test drive and go uphill at load, and then we are going to mark it as at load, the same data PID. It's important to do loaded and unloaded, because you could have an instance where you have a drivability problem. You have good idle, but you have bad performance at high revs. You need to know what you are missing. Okay, so let me quickly save this, and now we'll go for the loaded test. So next we do our loaded test, and you need some kind of road that has a moderate uphill or a steep uphill. We are blessed to have some good country roads, and we're going to do it here. You need to have your report ready and hit report immediately you are somewhere halfway where the throttle is right to the floor. So here we go. And we floor it. And as we're flooring it, we're going to hit report in 3, 2, 1. Here we go. Hit report. And now we've captured our loaded data. So now let me save this report, and then we're going to load up for the next ones. Our next test is our cam angles. So we're going to take the exhaust camshaft angle and the intake camshaft angles. And the first one is at idle, and right now we are at idle, so you're just going to hit report. Alright, so we're going to save this one. Now we'll take our cam angles when we are loaded. So we're on the floor, and we're going to get our report, hit report. And that's captured. Let's save that, and we do our next test. So now we take the turbo parameters and air parameters and a load first, and then at idle. So there we go on the load, and we'll hit report, and our report is generated. Alright, now we take the air parameters at idle. So right now we're at idle, and these are our readings. Generate our report. Now report is generated, and we'll save this as well. The AC was on, so we're going to retake this one right now at idle with the AC off, and our mass airflow has dropped down, and that is our values. I'm going to generate that report. Report is generated. Okay. Back at the workshop, and our last set of data is the engine temperature data, and these ones we typically take them at idle, no need to take them at load. 99 degrees centigrade is normal for these engines. They run, the manual actually says that optimal temperature for the engine, and that is the oil temperature, will run at 100 degrees centigrade, so that's normal. And for the engine coolant temperature, we're at 98. Our AC is on. Our AC is on, so this is the hottest the car will get because we are exchanging heat from the cabin to the engine bay, and that is our normal temperature. And how do I know that's normal? We have no temperature warnings on the dash, and we have no codes for over temperature. So I'm going to save this data as well, and that should be it for the OBD data. And next we're going to look at cam and crank correlation, and that will take at the engine ECU, and that will be our final one. Our last data set is our cam and crank correlation and our injector pattern. These are high-powered injectors. It's good to know how they open, how they close, and what kind of current they take. So first we're going to take the cam and crank correlation, remove the tire, peel back the wheel well, remove the engine computer which lives in this plastic box, pull it down, and we are taking our cam and crank from here. So we have channel 1 intake cam sensor, channel 2 exhaust cam sensor, channel 3 is a crank sensor, and channel 4 is ignition coil number 1. And I found that easier to take from coil number 1 right here. Scope is running, and we're going to start the car and pick our readings. So there were readings. This is a high resolution crank sensor, so you need to make sure that your sample rate is good enough to get it. If your sample rate is low, this will be choppy and you'll miss out on those. So once you've got that, that's at hot idle. We just pause it and we save that, and that gives us our good cam and crank correlation. Now we want to relocate our leads to pick injector voltage and injector current, and that will be the end of our data capture. Next data capture is for the injector signals. This is a direct injection engine. Direct injection engine have high powered injectors, so we want to see what injector signals they have. Nice of Volvo to put an injector sub harness for all the injectors here. I wish all manufacturers would do the same thing, so we can easily get to the injectors. So channel 1, I'm taking injector positive line. Channel 2, I'm taking injector negative line. And then I do not want to mess the harness by peeling it back. These are really neat. So channel 3, I'm going to take my injector current at the ECU on the positive line. Current clamp is set to 20 amp, and my scope is running, and now we'll start the car. And there we have our injector pattern. That's really good. I'm going to pause this. You can see here that these injectors take 8 amps a piece, and it is a high powered injectors. It's powered by 62 volts. Now let me show you something here. These injectors sometimes are powered and are not powered, but they're still pulsed on both lines. I have set my trigger on the current so that you can see only the active state. Notice that the ground, this is not really a ground. Before it is grounded, this injector is held at about 2 volts. In fact, that's how the ECU is able to check that this line has got good integrity. If it sees that 2 volts return through the injector back, it knows that that line is continuous. Same here, it has the same bias voltage, about 2 volts, but it's grounded here, and then when the injector opens, this is a peak and hold style control. So it peaks the current and then it holds the current here, and then when the current goes off, that's when the injector turns off. And that's where you see our regular injector profile with the pintle hump on this side. But I want to show you what happens when you don't put a trigger on the current clamp. Let's first put the trigger on channel A. And look at this. You see sometimes the current appears and disappears. That's because there are times when this injector is pulsed on both lines the same way and it's not activated. And how you can tell that is simple. I'm going to bring this here. Go back to triggering on my current. And then hold, not hold, but drop my time base. And then I'm going to pause this. And now you see here, we have injector control on this one. And then on our next pulse, we are going to have both lines being pulsed at the same time. Let me just scroll with this. There you go. So you have both lines being pulsed at the same time, and we can just verify that. 64 volts, and on the red channel you also have 64 volts. Another way of verifying it is just taking this, sliding up and overlaying it, and you'll see that those two lines are exactly identical. So why do we have no current flow? 64 volts on positive, 64 volts on negative, no potential difference, no current flow. And then the next pulse will be 64 volts on the positive and ground on the negative. That's why now you get a pulse. That's a characteristic of these cars, and that's how it's always done. One more reading here. Charging voltage on the car is at idle. I don't want to assume. So we're going to start the car. Right now we're at 12.7. Nice, so this one charges at idle, 14.2. Very good. And that's it for our data acquisition. I just want to show you how organized data will really save your time in the field. You do not want your data to be disorganized after spending so much time collecting it. And you want it easily accessible when you're doing diagnosis. I usually have a server and I'm developing my own technical information system. I've been asked several times, why do I do this? The answer is simple. In Africa, we do not have access to all our major data sites. I'm talking about all data, auto data, Haynes Pro, Identifix, ServiceBox, ElsaWin, WIS, etc. We do not have access to these databases. Now, personally, I don't let that stop me. I have partnered with very understanding people in the US and in the UK, and I can log into those accounts and download what I need. But it's not something that I like to do often because I don't like bothering people. So I just make my own whenever I have a chance to make my own database. I just want to show you how it ends up looking like. For me, this maybe inspire some of you to do your own. And remember to put this online because you need to have it online or some kind of remote connection when you're doing diagnosis. So here we have the overall live data at idle, and then our air and turbo pressures values at idle and at load, and then our fuel pressures at idle and at load, VVT angles idle and at load, and then our nominal engine temperatures. So this is what we gathered. And then in the engine management, we have our cam and crank correlation, a very quick view of one engine cycle. There it is. A very quick zoomed in view if you want to see where the teeth are. And my picoscope data file is accessible here whenever I need it. And that will just open picoscope, load the file in there directly, and I'm good to go when I need to do a diagnosis. So just wanted to show you how I do it. This is how I do it. And again, all this work behind the scenes is what makes my business very successful. The amount of time you spend prepping for your business will eventually translate in the amount of money that you make. Just an inspiration, and that's it for this video. See you next time.